the UK has faced its fair share of challenges on its journey to maintain its status as a Tier 1 military power. The Royal Air Force confronted an array of strategic threats, all while dealing with resource limitations and various other hurdles. These challenges have occasionally pushed Britain to reevaluate its strategies and invest in advancing its aircraft technology. But now, they've made a remarkable comeback with an invention that promises to revolutionize aerial warfare. This extraordinary fighter jet is brimming with cutting-edge weaponry and state-of-the-art systems, propelling it to the forefront of sixth-generation fighter aircraft. With this innovation, even the enigmatic American UFO fighter jet takes a backseat. The UK's strategic collaborations with international partners has successfully brought to life one of the most ingenious and awe-inspiring aircraft the world has ever seen. Join us as we delve into how the world is shocked. The new British fighter jet surpasses the UFO aircraft. The emergence of a sixth-generation European fighter jet is nothing short of remarkable, given that Europe has predominantly relied on fourth-generation fighters, while the US and China have already ventured into fifth-generation aircraft. The Eurofighter Typhoon used to be reliable. It was recognized as the best fighter jet within the European Union. With a top speed of 1,500 mph, a soaring flight altitude of over 50,500 feet, an extensive array of weaponry and dependable avionics, it has served well. However, even such a formidable fighter must take a backseat, as it was developed over 25 years ago. So, it's high time for a technological leap forward, and the success of a fighter jet largely depends on the expertise of its developers. Thankfully, this new project, called the Tempest Project, has assembled a team of military specialists from various countries, including the UK, Italy, Switzerland, and Germany, to collaborate on this groundbreaking endeavor. BAE Systems and Rolls-Royce are just a glimpse into the cooperative development approach. It's a practical strategy, as only a few EU countries can afford to individually create a new generation fighter. Moreover, many nations lack the necessary technical infrastructure. The Tempest project demonstrates that by combining efforts, knowledge, and budget, it's possible to create an aircraft that can outshine the competition. One notable feature of the Tempest is its variable wing shape, which can be adapted to suit different conditions and tasks, offering enhanced speed and maneuverability. Equally crucial is the engine, where Rolls-Royce excels. Despite the complex nature of hypersonic engines, the Tempest engine overcomes challenges, including cooling components at extreme temperatures. This powerful engine propels the fighter jet to an impressive speed of 1,860 mph, with 2 flight modes and a hydrogen tank for short bursts of flight at 2,800 mph. Rolls-Royce engineers are presently conducting aerodynamic tests on the engine, using innovative manufacturing processes to create a unique air duct. This design aims to slow down supersonic airflow to subsonic speeds, maximizing stealth and fuel efficiency. With such an engine, the Tempest can outpace the American NZAD fighter, which operates at a top speed of 2,200 mph, setting the stage for potential victories. Moreover, the UK's laser-directed energy program, led by missile systems manufacturer MBDA, has already initiated tests on new laser weapons. This collaborative effort involves the UK Ministry of Industry, UK Ministry of Defence, MBDA, and Leonardo, all companies deeply involved in the Tempest project. The laser system, capable of both offensive and defensive operations, delivers a staggering 300 kilobars of power. It harnesses infrared radiation directed at the enemy, heating their materials to thousands of degrees. This innovative weapon poses a grave threat to various vehicles, as it causes shells to ignite and detonate, tearing the target from the inside due to the intense heat. With this formidable laser cannon and its remarkable speed, the Tempest can infiltrate enemy bases and obliterate key positions with remarkable precision. And if you're thinking of taking the fight to the Tempest, think again. It operates at an altitude exceeding 65,500 feet, a height largely beyond the reach of most modern air defense systems. It also sports a modern stealth skin, a significant advancement from older fighters. Unlike previous models, where radar-reflecting coatings were employed, the Tempest uses an innovative composite material. This material is not only durable and lightweight, but also incredibly effective at evading radar detection. The Tempest indeed brings several fascinating features to the table. To further bolster its radar-defying abilities, the Tempest incorporates a radar jamming system. This system emits precisely tuned waves that disrupt enemy radar, making it challenging for adversaries to pinpoint the aircraft's location. Moreover, BAE Systems, one of the leading companies involved in the Tempest project, has announced the implementation of new software for safety-critical systems, employing automatic coding. This software approach not only safeguards the fighter from remote hacking attempts, but also shields it against interference generators. This comprehensive software approach also enables the rapid evaluation of flight control system performance during complex maneuvers. The use of simulators provides crucial insights into how the aircraft will perform, long before its first flight. In fact, Royal Air Force pilots have already accumulated more than 150 hours of flight experience using the demonstration aircraft in a specially designed simulator. This ensures that when the Tempest is ready for deployment, it will be operated by well-trained military personnel. However, one intriguing aspect of the Tempest's design is the integration of unmanned systems, presenting a paradigm shift in military aviation. The Tempest incorporates three types of unmanned systems. Firstly, it employs artificial intelligence within its onboard computer, enabling remote control and potentially autonomous operation. Imagine an unmanned fighter jet armed with a lethal laser weapon patrolling the skies. The second unmanned system is a surveillance drone that works in line with the Tempest, facilitating the collection of intelligence over a vast area equivalent to more than 250 football fields. This capability enhances the fighter's situational awareness and decision-making abilities. The third system, an augmented reality helmet, plays a crucial role during intense aerial battles. Given the Tempest's incredible speed, a pilot may struggle to react effectively to rapidly changing situations. The augmented reality helmet bridges this gap by transmitting information from the fighter's sensors directly to the pilot's head. This real-time connection fuses the pilot's cognitive abilities with the aircraft's systems, creating a seamless integration. Moreover, the helmet's sensors can monitor the pilot's brain signals and other physiological data. Over time, this smart helmet accumulates a unique psychometric database for each pilot, enabling the onboard computer to intervene when necessary. With the mesmerizing features and capabilities of this jet, people have concluded that it's much better than the UFO aircraft that is rumored to have been created by the U.S. Air Force. This aircraft, known as Aurora, has allegedly been sighted only in the U.S. and the U.K. On November 29, 2014, residents in the southern parts of the U.K. and the east coast of the United States were startled by a series of loud and mysterious sounds. A recording of these perplexing noises, captured by a London resident using a cell phone, quickly made its way to the internet. To this day, the exact source of these sounds remains a mystery, leading to various speculations. However, one of the most intriguing theories was the flight of the Aurora, the mysterious project linked to the U.S. Air Force. Media reports suggested that witnesses had frequently observed peculiar flying machines in the shape of massive black wings in the sky. While some thought of them as UFOs, others dismissed the notion of alien involvement, attributing the sightings to a top-secret U.S. aircraft. The TR-3B Black Manta aircraft is a top-secret component of the Aurora project. Some of its technical features have been disclosed. This aircraft is said to be equipped with a combined engine featuring turbojet and ramjet circuits. Its hypersonic capabilities would be enabled by pulsating combustion of fuel, providing speeds 10 to 15 times faster than the speed of sound, at altitudes ranging from 35 to 36 kilometers above the ground. Most remarkably, the TR-3B Black Manta is rumored to incorporate an anti-gravity device capable of reducing its massive weight to nearly nothing, although this would require a substantial amount of energy. To meet these energy demands, a compact nuclear reactor is rumored to be on board. While we have no data on the aircraft's aerodynamics, some say it bears a resemblance to the infamous F-117, despite its speed of 37,000 km per hour and a ceiling of 27 kilometers. The notion of anti-gravity technology might sound like pure fantasy to many. After all, gravity is considered a fundamental property of any material body. However, it's worth remembering that in the 19th century, submarines were also regarded as science fiction, so we may still have a lot of discoveries to make. Even with the remarkable abilities of the Black Manta, though, the Tempest surpasses the mysterious UFO aircraft in terms of general performance. Comparisons between the Tempest and the American NGAD are inevitable as well, as they share several key features. Both aircraft are AI-controlled, armed with powerful lasers, and excel in radar-evading capabilities. While NGAD is primarily a U.S. initiative, Colonel Metrolese expressed a willingness to welcome the UK's input on sixth-generation development and deployment. However, the specifics of this potential collaboration remain uncertain, particularly concerning the core components of the NGAD and the UK's Tempest program. Also, what distinguishes the British Tempest is its focus on ease of modernization. The aircraft is designed to accommodate swift upgrades, much like downloading an app to a smartphone. This future-ready approach ensures that the Tempest can quickly adapt to specific mission requirements. Pilots can access the necessary settings with ease, allowing them to operate the aircraft in autopilot mode, confident that it's optimized for even the most challenging tasks. While the NGAD program has had a demonstrator in flight since late 2020, it remains concealed from public view. By most accounts, it's expected to feature a heavy, tailless, stealthy design that diverges from traditional fighter aircraft. Key attributes of the design are likely to include long-range capabilities, high payload capacity, advanced sensor fusion, situational awareness, connectivity through advanced networking, and a high degree of stealth. The focus here is on survivability and range, though it's worth noting that these advanced platforms come with significant costs, potentially reaching multiple hundreds of millions of dollars per unit. An intriguing aspect of NGAD's manned fighter component is adaptability. There is evidence to suggest that the U.S. Air Force is considering two different configurations of a single design. One configuration would be optimized for European operations, while the other would be tailored for long-range, long-endurance missions in the Pacific. The latter configuration appears to be the primary focus. Going back to the Tempest, we know it's also designed as a sixth-generation fighter. It is characterized by a higher level of automation and cutting-edge technologies. These advancements extend to communication systems and countermeasures against enemy electronic warfare, further cementing its status as a formidable asset in the world of military aviation. However, before the advent of the Tempest, some cutting-edge aircraft have ruled the skies, and some of them are still ruling. When it comes to exceptional fighter jets like this, the F-22 Raptor unquestionably earns its place in the spotlight. It's a marvel of technological progress, boasting a maximum flight altitude of 62,000 feet and speeds reaching a staggering 1,500 mph. Notably, the F-22 Raptor was adopted and tested at an accelerated pace compared to its international counterparts. While its performance is impressive, the F-22 Raptor also holds the distinction of being the most expensive combat aircraft in aviation history, with a price tag of $146 million, excluding development costs. The aircraft's design places a strong emphasis on survivability, with a cockpit crafted from polycarbonate glass, featuring a special radio wave scattering coating. This design not only enhances radar evasion, but also fortifies the aircraft against high-explosive munitions. A standout feature of the fighter jet is its radar system, consisting of 2,000 elements. This sophisticated antenna can detect targets at a remarkable distance of 140 miles and cruise missiles from 77 miles away, setting a high bar for fighter jets. Originally designed to secure air supremacy, the F-22 Raptor excels in air-to-air combat, making it a formidable adversary for modern aircraft. However, it's not as adept at engaging ground targets. Interestingly, the recent unveiling of a new concept model of the Tempest at the Farnborough International Air Show showcased a design with striking resemblances to the US F-22 Raptor, with elements reminiscent of the Northrop YF-23, a competitor of the F-22. Now, let's shift our focus to another impressive contender, the F-35 Lightning II. This fifth-generation fighter jet stands out as a technical marvel, equipped with engines that propel it to speeds of 1,200 mph. The unique feature here is the ability to switch to vertical thrust mode, allowing the F-35 to operate without a traditional landing strip. This capability led to the F-35 becoming the sole fighter used on aircraft carriers, an impressive feat considering it isn't a deck-based fighter. Another pivotal factor contributing to the F-35's popularity is its remarkable invisibility. As detection technologies continue to evolve, invisibility to radar has become a paramount concern in aviation. The F-35's design hones this aspect to perfection, incorporating reflective plating, a low-profile shape, and a technology blocking system that renders it elusive to radar detection. Moreover, the F-35 is equipped with a remarkable pilot's helmet that features a built-in display, providing vital combat information directly in the pilot's line of sight. This feature proves invaluable during intense aerial combat scenarios. The F-35 really leaves no room for doubt. It's armed with ASRAAM-guided cruise missiles for larger air targets, capable of accelerating to speeds exceeding 2,500 mph. For smaller adversaries, a 4-barreled 25mm cannon swiftly turns them into a sieve. When it comes to ground targets, the AGM-158 cruise missile, weighing a ton and designed for precision strikes on well-protected objectives, is the weapon of choice. This missile is known to excel even in adverse weather conditions, but there's more to the F-35's arsenal. It boasts HARM anti-radar missiles, effective at detecting and destroying enemy radars. Additionally, the aircraft has the capacity to carry cluster and nuclear bombs, underscoring its versatility. What's even more exciting is the potential addition of real laser weaponry to the F-35's arsenal. Engineers are actively developing an onboard control system that leverages artificial intelligence with self-learning capabilities. This approach redefines the pilot's role, transforming them into key decision-makers while delegating numerous tasks to automation, making the F-35 an aviation complex of unparalleled sophistication. Also, we should explore some worthy adversaries that, surprisingly, belong to the previous, fourth generation of fighters. One such aircraft is the F-16 Fighting Falcon, a venerable jet with over 10 main varieties and an equal number of local versions. The most modern iteration is the F-16V, boasting several remarkable features that have contributed to its acclaim. With a length of 49 feet and a wingspan of 31 feet, the F-16V is highly maneuverable and compact, making it ideal for swift and surprise attacks. What's even more impressive is its ability to carry up to 21 tons of payload, including homing anti-tank missiles, air-to-air missiles, and a radar jamming system, a comprehensive arsenal capable of dealing with various threats. While its top speed of 930 mph is slightly lower than the F-35's, the F-16V possesses a numerical advantage with over 4,600 units produced compared to the 900 F-35s currently in operation. This numerical superiority holds strategic significance, allowing for a formidable swarm capable of overwhelming technologically advanced adversaries. Over the years, developers realized that the F-16's potential exceeded its current capabilities. This led to enhancements in stealth, avionics, controls, structural strength, and armament. The incorporation of millions of microparticles of a special substance on the aircraft's surface significantly bolsters its radar evasion capabilities. There's also the FA-18, a versatile fourth-generation fighter jet that serves as both a fighter and an attack aircraft. The Super Hornet, which took to the skies in 1995, set new standards in multiple aspects, including layout, electronic equipment, radar capabilities, and the use of radar countermeasures. Its radar, with a remarkable range of up to 90 miles, marked a historic achievement. Moreover, the FA-18 was among the first to employ a system designed to counter enemy radar. With a focus on versatility, the Navy sought to enhance the Super Hornet's range, survivability, and armament. This comprehensive approach is driven by the need for a versatile aircraft on aircraft carriers. As a result, the Super Hornet stands as a jack-of-all-trades, capable of fulfilling a wide range of missions. It can carry a dozen AIM-120 air-to-air missiles, ideal for supersonic engagements, and AGM-158C stealth missiles designed for anti-ship operations. High-precision bombing with up to 10 bombs in a single flight is also well within its capabilities. Surprisingly, the FA-18 is even equipped to function as an air tanker. Its resilience is further demonstrated by its adaptation to the rigorous demands of catapult launches, hard landings on aircraft carriers, and exposure to salt water. The Super Hornet's prowess and versatility are unquestionable, yet it's intriguing that it hasn't reached the same level of popularity as the F-16, despite a lower price tag of $53 million compared to the F-16's $57 million excluding weapons. While both the F-16 Fighting Falcon and the FA-18 Super Hornet are undeniably impressive in their own right, a new player is poised to redefine the aviation landscape. Beyond the Tempest and NGAD, there is also the Dark Star, a sixth-generation fighter jet currently in development, with capabilities that push the boundaries of what's possible. The Dark Star's specifications are truly awe-inspiring. It can achieve speeds of 4,300 mph, operate combat and reconnaissance drones, utilize the most powerful laser weapons, employ advanced stealth technologies for invisibility, and maintain continuous flight thanks to artificial intelligence control. Although it remains in development, it is already a strong contender for the title of the best fighter in aviation history. But will the Tempest allow that to happen? We can only anticipate how things will play out in the coming years. Thanks for watching. While you're still here, click on the link appearing on your screen for another of our interesting videos. See you there.